Yeah. And it's going up. Hey, everybody, welcome back to the Sustainiacs. I am Michael Vincent. I've got a new Sustainiac. Well, he's not a new Sustainiac. He's been a Sustainiac for a while, but he's new to the show. His name's Tim Noonan, and he is the founder and CEO at Evertrak, correct?
Correct.
You're also a Marine veteran. Thank you for your service, my friend. My father was a Marine.
Well, anybody who had a dad as a Marine is an honorary Marine.
Well, thank you, sir. He was Korean War. He was recon.
Really?
Yeah, and he built our house, and every single room had its own circuit breaker. So if I was grounded for not making my bed to specifications, I was grounded to my room, and I had no power.
Is he still with us? Is your dad still with us?
He is not with us, unfortunately. He is not. But yeah, he was. That's how I grew up. So how am I going to get up to go to school? I leave for work at 5 a.m. Be ready. But school's not there till 7 o'clock. You can wait outside.
Right. That's right.
That's how it was, brother.
Told
But how
my
are you,
kid,
man? What's going on?
cold builds character.
Yes, it does. Yes, it does.
No, we're in St. Louis where it's cold, which is a great weather for making railroad ties out of recycled plastic and glass fiber. And we are, figuring out how to blow up this wood railroad tie industry because the world's run out of 100-year-old trees to make railroad ties, and we got forests of plastic right outside our door. So we should just use
Forests of plastic. I didn't know St. Louis was in a forest of plastics.
the world's in a forest of
Yeah.
the ocean's in a forest of plastic.
It really is. And the other, I mean, the wood railroad ties aren't exactly just a nice piece of wood either, right? I mean, yeah.
No, I mean the biggest innovation. Well, the biggest innovation in wood ties was the fact that they were, hundreds of years old. And the second biggest innovation was the fact that they needed something to do with this, with this tar that came out of burning coal, and they created creosote, and then creosote ended up being a great treater for wood, but for the fact that it causes cancer, and is still the industry standard to today. The only place you can use creosote in many states is for railroad ties. You can't use
Is it so? Okay, so what are they using in the railroad ties for, like, landscaping?
Those probably don't have creosote in them anymore, unless you
No,
go buy, unless you go to Menards or Home Depot, and
an actual railroad
you
tie.
can buy an actual railroad tie.
Yeah. Okay.
But they if you're using any kind of sustainable gardening practice or any kind of gardening at all, you wouldn't use a creosote tie. You might use it for
I just
hanging
wonder how
rock.
many raised tomato beds there are out there that are made out of
Exactly, with
actual
creosote.
railroad ties.
Yeah, exactly.
You know what I'm saying? Because it causes cancer, but there's nobody going around the railroad, like chipping off wood and chewing on it or smoking it or anything like that, right?
No, no,
But it leaches into the
yeah, it
water
leaches
system.
into the groundwater, and these big, like, down, I think it's in Houston, there's a couple cancer clusters that are related to creosote treatment. So any place that they've done this creosote treatment, I mean, it's kind of like PCBs. I mean, it just,
Oh, like you mean around an area where they're treating wood
yeah,
with the creosote, and then it
yeah,
leaches into the local groundwater,
yeah,
etc. Okay,
yeah.
gotcha. Yeah, that's all right. I see it. So, what exactly? What are you guys building? Give us a lowdown on Evertrack. What are you guys doing, and then let's get into why and how and just
Yeah,
kind of
yeah.
go into.
So there's about the United States railway system, that really sprang up in the mid 1850s. You got to keep in mind that it's so interesting that talk about a government that could do two things at once during the Civil War. on I believe it was the day of the Battle of Antietam Creek. Abraham Lincoln signed the Transcontinental Railroad Act that created the Transcontinental Railroad. And as you know, this was a big deal for the Lincoln administration, which was to connect the East and the West
Yeah.
through rail. And they would go and cut down trees and make railroad ties. And railroad ties are the steel sits on a railroad tie, which is made from wood, then sits in typically granite, what's called ballast. And that was the
That's
innovation.
the
And
that's the that's the gravel. The ballast is
that's
the
the
gravel,
gravel. It's called the
and that
ballast.
and that's to be able to give way for hot and cold and try and keep it level at the same
Yeah, it's a
time.
big
Really?
it's a big insulator. It's a big foundation. It's big. It's foundational.
Yeah, yeah, yeah,
It
yeah,
creates a foundation. It allows the tie to sit and not slide with lateral stability.
yeah,
Um,
yeah, yeah, yeah.
but the interesting thing about the railroads in the United States as they've evolved is that they're mostly for heavy haul freight, which is a lot different than other countries where they're mostly for passenger.
Yeah, that's
So
one thing people don't really realize is freight doesn't move on rail in like Europe. It mostly
no, it doesn't.
no, it's truck and then people move on.
People and
Yeah,
rivers and canals and
yeah.
but in the United States, moves by rail, and you have this installed base of it's an arguable number. It's 550 million to 700 million of these wooden railroad ties that
What
are
is that current?
installed.
Current right
That's
now?
current. Yeah, that's currently 100 and 30,000 miles, 3 to 3,200 ties per mile. So there's hundreds of millions of these wooden railroad ties, and I've never built the model, um, but you can imagine you have these really dense trees that and then the ties are soaked in creosote and they last a longer time. And even there was bugs and moistures in the southeast, but as we run out of these old growth trees and we not using as much creosote and haven't found a chemical or a species that can put up to the wear and tear of the bugs and moisture in the southeast, there's typically about 18 to 20 million wooden railroad ties replaced every year in North America, about 3.5% of the installed base.
Yeah, I was going to ask what is the percentage that's sitting around waiting to be installed as well?
About
18 million.
yeah, my sense is that the inventory numbers are probably half the installed base, but the so just real quick, so in that 3.5%, um, there's about a third of that is really high velocity railroad ties that are being replaced 10 to 12% in the southeastern part of the United States. So of that, say 18 million,
Oh,
so say of
yeah.
the 18 million ties that are replaced every year in North America, 6 million, this high velocity turns are happening around 4 to 6 million in the southeastern part of the United States.
Gotcha, gotcha. So it's disproportionate. It's
It's
yeah, yeah, you yeah,
disproportionate. Yeah.
yeah,
And so,
yeah.
our thesis is that if we could make a railroad tie that was as strong as wood, that had the engineering properties of wood, which is mostly measured in strength and stiffness, so the ability to bend without breaking and then not deform. And then there's some things about thermo expansion that when it gets hot, does it get wide or narrow? We believe that we could have a new conversation with the railroads around, instead of thinking about a railroad tie as a commodity, that you just buy as many as you can afford. Think about it as a different commodity where you buy on total cost of ownership instead of price. Because once you're if our customer Union Pacific says they believe our tie will last 50 years. if you're talking about something that lasts 50 years versus something that lasts 10, you get, you get 5 ties, but then you got to install it 5 times. And then you got to you got to pay to get rid of a creosote tie. That costs about $10 a tie. You got to pay to get rid of that. And your operations are impacted. So, again,
Mm.
our thesis is that, let's take this affordable, abundant, wide spec plastic that there's not a huge demand signal for. Let's engineer it into a product, and then let's go keep trees from getting cut down.
Unbelievable. And why does it have to be replaced? Why does it only last 50 years? Is it because it breaks down due to just wear and
Well, we don't
tear?
exactly. We don't know if it. Our it's a great question. Like only last 50 years. Like it's a long enough time frame that is way beyond anybody's ability to imagine.
Right.
But who knows if it would last longer? I mean, it'll last longer than the steel. The steel will last 20 to
Is
30.
that right? So the plastic railroad tie you're building is it through engineering means, you study it, you know what the tensile strengths are and the makeup, etc. It's predicted to be 5 times longer than the steel?
No, 5 times longer than wood, but
Yeah.
it'll outlast the steel. The
Okay.
steel will wear out before the tie.
That is interesting. That is really
Yeah,
interesting. And then and then both the steel and the tie can then be recycled and
that's
repurposed.
right. That's right. And, unlike wood that you need to handle as a
It's just
hazardous
done.
material. Yeah, and
Yeah,
you
and
have to
it's just
pay.
done. You can't recycle it into anything
Can't
because
recycle it.
it deteriorates and falls apart, right? I mean,
That's right. And
it's just
and then
yeah.
the railroads have to pay to get rid of that tie. That there's I know that there's one class one railroad in the southeast that has millions of wooden railroad ties just stacked up on their right of way, figuring out what to do with them. I mean, you got to allocate cars.
Yeah, you can't burn them.
You can't burn them. You got to landfill them. You landfill them. You got to pay exorbitant fee. So every one of those ties costs about $10 to get rid of.
Yeah. So our solution to a carcinogen being buried in the earth is just pay money and it'll be okay.
Oh, that's right. Yeah, problem solved with money is not a problem.
Probably, yeah. Just give some money and then it's not a problem anymore. Right? That is completely ridiculous. So why are okay? What is your background? How did you get into it and why?
Yeah. So my background in the very near future or near past is that I retired from Boeing in 2017, and most of what I did at Boeing, my last job at Boeing, which is one of the great, despite everything that's going on, is one of the great companies ever in the history of the world. Um, but my last job at Boeing is I ran our defense training business. So taught people how to fly, fight, and fix our airplanes, and had a couple other programs. But
Oh,
mostly what I
really?
did, yeah, but mostly what I did at Boeing is commercialized technology. So we started a little ventures business. We had this thesis that inside Boeing, inside any big company, entrepreneurs are everywhere. They just might have landed at a big company, and how do you find them, and how do you give them skills, and there's sort of a deep portfolio of things that we could bring and commercialize at Boeing. So spent a lot of time doing that. And so as I was thinking, I took an early retirement from Boeing, and I had invested in a local plastic recycling business. And as we were staring at that business, we kind of said, well, where can we take the plastic and put it into um, a part? How do we make something? And landed on the fact that no one had really fixed this composite tie using recycled plastic for composite ties for a bunch of reasons. um, that included uh, the innovators kind of listened to their customer and they said, "Oh, we want something as cheap as wood, but they really need something as strong as wood." Um, they lost lock on manufacturing quality. They lost lock on supply chain quality. So we built a tie, and our goal was to make it as strong as wood, not as cheap as wood. If it was as strong as wood, it's going to be more expensive. So it's another value proposition, and there's just a really long testing cycle. I mean, we kind of needed to test for years, 3 to 5 years, to really get the confidence of our class one
Yeah,
customer.
you've got a rather large piece of machinery flying down a rail, and you don't need the track to or the tie to fail.
Yeah, that's right. I mean,
I
and you
can
do lot,
imagine.
yeah, and you can do lots and lots and lots of accelerated physical testing, which we did at some labs that the Federal Railroad Administration has. And you can do lots of finite element model analysis. You can do lots and lots and lots of things, but at the end of the day, it's a physical thing that's you know sitting out in a really remote location getting beaten on all the time.
Yeah, and nobody's going to be inspecting it every day. I mean, how often are
That's
you
right.
inspecting those ties? Not probably that
Not
often.
often. Not as much. Annually at best. I think the railroads are working on some technology that'll allow sort of more continuous monitoring. Where you can
At least visually.
put a device on a locomotive and have it constantly be getting data, but they're not quite there yet.
Yeah, I guess it would be compression type of thing, which could indicate a bunch of things, not only just the tie, but the foundation underneath it.
Yeah, you get a lot from vibration.
Yeah.
A lot from vibration and heat.
Yeah, it's very very interesting. So what kind of what kind of plastics are you guys using in it in the
We
tie?
use predominantly high density polyethylene with a little bit of polypropylene. We've got the big challenge in manufacturing a consistent product from recycled plastic is that there's a wide spec of recycled plastic.
Yeah,
As
huge.
as Americans, single stream recycling is just another word for garbage. People just throw everything in that thing, and you know it, who knows, right? And so we've worked with dozens dozens and dozens and dozens. We've probably talked to 100 suppliers. We've got 3 or 4 that meet our spec, mostly around melt flow, um, kind of cleanliness. You need all the wood and fines and all the stuff out of the plastic,
Yeah. The contamination
and
levels.
moisture content.
Yeah.
So we really really focus on that. Supply chain quality is really 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 important.
Well, it's very difficult. So you guys are is it an extrusion method that you guys are using to?
Yes.
Okay, so yeah, moisture content, et cetera, is highly important, and melt flow. But so you're not exclusively using like post industrial or post consumer. I would imagine
No,
whatever it is
we'll
that
use
works
either.
works.
We love post industrial because it's clean. It's
Yeah. Oh yeah,
typically
it's much more consistent
had
quality.
had
Yeah.
one had got really long polymer chains. The it's only had one heat cycle that goes through it. You heat plastic up 3 or 4 times, and the polymer chains break down. It flows a lot more easily, but it doesn't. You get less. You get less. Contact between your glass fiber and your polymer chain. So,
So you're mixing it. Are you mixing it with glass fiber as well?
uh-huh.
You
Yeah.
are. So is that glass fiber? So is that that's not something that you could is that recycled glass fiber as well? Can
No,
you?
it's virgin. It's
So
virgin.
does it have to be virgin? Is there?
Yeah, it has to be virgin for a couple reasons. One is you need a really, really consistent length over diameter. You
Uh,
gotta control L over D, and you have to control the binder. typically called a silane. That the binder, is what allows the individual piece of glass to kind of stick to the polymer. Which is
Gotcha.
why I kind of push back with, oh, it's a plastic. It's like it's not plastic. It's composite. I mean, it's 1+1 = 3. Because
Yeah, yeah,
plastic
yeah, yeah.
plastic without it's like concrete without rebar. You know,
Yeah. Yeah, yeah, exactly, exactly. So yeah, it's kind of like steel reinforced. So it's glass
right,
reinforced plastic is
right.
basically what it is. So it's really so you can't use like a recycled like uh, glass. You couldn't use like wind turbine blades or anything
No,
like that.
no, not until they figure out a way to extract those. My sense is that those are kind of laid down in mats. It's probably a woven like a
Oh yeah,
woven.
yeah, yeah, yeah.
To,
Gotcha,
to do that, they'd have to figure out a way to extract those individual pieces of fiber so they end up individually. And
gotcha.
that doesn't mean there might not be a use for that at some point, but
Just the
right now
recycle process isn't there yet.
it's not there yet. And then the more steps you add, the more expensive it gets, and then at some point you're just like, well, just as good to use virgin.
Gotcha, gotcha.
And the fact of the matter is that you know um, the railroads have an engineering problem, and the
Okay.
engineering problem is that they need something that's not wood that's as strong and stiff as wood.
Yeah.
If we could get, the reason we use recycled plastic is that it's much cheaper than virgin. If we could figure out a way to do it with virgin, we would get completely consistent product, but it would be very expensive.
Wait,
And
okay. Now
so
this is one of the few times that I've heard that the recycled plastic is cheaper than the virgin.
it's cheaper than virgin. Yeah.
That's amazing. Is it the type of plastic that you're looking for that causes that makes that way
No,
or?
I think it's the fact that how the form factor that we use our plastic is that we don't use pellets, we use regrind.
Oh, okay, I
So
got you. Yeah, yeah. So
yeah,
you don't have to process it right down all the way through a pellet.
it doesn't need
You're
to be
not going through
processed.
a compounder or any of that type of
Correct,
stuff.
correct.
Gotcha. All right, that makes that now that makes perfect
Yeah,
sense.
yeah,
Okay.
yeah, yeah. It's not
Yeah.
going through a compounder. It's not turned into a pellet. It's we use regrind flake, which is much more affordable than virgin.
Yeah, it absolutely is, and especially if it's well, yeah, it just is. And for people out there who are listening who don't into recycling all that much is just you take you take a bottle of whatever it happens to be or purge from an industrial complex, industrial manufacturing rejected parts or whatever it is, and you just grind it. You're
Yep,
literally just sending it through a grinder, like you
yep,
see the videos of a grinder that eats up a car engine. You're
yep,
basically just throwing plastic chunks that might be purge, which can look like almost like lava type of stuff, right? The
yep,
chunks that come out, chip it up into small enough pieces, and that's all you need.
yep. That's
Maybe
all we
a
need.
maybe a, maybe a light wash to make sure
We
there's.
don't even wash it. That's a value added step that our
Oh, that's
suppliers.
fantastic. That
Yeah,
is fantastic.
yeah.
Yeah.
Well, and we've got some things that we do to control melt flow, but it's all recycled plastic.
Yeah, that is that, and it's cheap. So is your tie cheaper than wood?
Not yet. It's got a
Is it just scale that gets it there?
yeah. I mean, I think we live in a world where tell me how much it weighs, I'll tell you how much it costs, and so I think there's two things that get us there. One is just sheer scale. If you're, I think no matter what happens, if you want to be the trusted low cost producer, you've got to work at scale, and you can never forget, that your customer, despite the fact they have a problem, they've got a way to solve it. and they've got the infrastructure set up to solve it. They just
It's
replace
already
one loop.
there. Yeah.
Yeah, it's already there. So, they need an alternative that fits inside their budget profile. So there's kind of two things to do. One is scale. You get better absorption. You get better leverage with your suppliers. You get your factory turned on. And the next is product development. So I think there's a number of things that we're going to be able to do with advanced materials and advanced manufacturing that are going to make this thing much more affordable. And I think the third thing you could do um, to get to scale would be to create some sort of financing or leasing mechanism that allows you to kind of fit inside the budget profiles until the future cost savings pays for the current program. The thing that you find with your railroad customers is that their cost of capital is so low that it's really, really hard to create any financing solution that would make sense to them.
Yeah. So the only other thing is then some sort of incentivized program through the government to adopt it, which
Or an incentivized program through the
yeah,
government. That's
yeah,
exactly right.
which right now is stressed to say the least.
Yeah, I think there's a couple shots on goal there. I mean,
Yeah.
there's a couple programs through the FRA, and I think with this, business minded administration, if you can point to a total cost of ownership advantage that accrues to the
Yes.
user,
Yes. Yes.
accrues to the user,
Yes.
and gets an industry to scale and stimulates plastic recycling in the United States and prevents the cutting down of trees. Now, people are going to complain, oh, the wood lobby this and the this lobby that, but I think it's really hard to push back against. Um, yeah, we need to keep putting more plastic in landfills. That's a great idea. Let's keep putting more plastic. That's a great
I
That's a
think
great
it's
idea. We got to keep the
dig bigger
landfill.
holes. Dig
Yeah,
bigger
we need to
holes.
keep the landfill. We need to keep the landfill industry going strong. Oh
Well, I
yeah,
mean,
really,
listen, that's a joke to me, but it's also a reality.
it is a reality.
There's a lobby out there trying to keep the landfills accepting as much garbage as
Yeah,
possible,
that's
and
right. And there's
they're against composting, they're against recycling, they're against that stuff because they get paid tipping
no,
fees
that's right.
in
And
order to put it in there.
and the
Yeah.
same lobby exists for, hey, sustainable forestry. We plant 3 trees for every one we cut down. It's like, yeah, that's true, but three
That's only sustainable for a certain number of decades,
yeah,
though, right?
three 30-year-old trees does not equal one 90-year-old tree.
Yeah, no, it doesn't. It doesn't even come close. Yeah, you're
You
right.
know, so I mean, these are, and keep it in mind that your customer, this customer will take the sustainability win, but it might, all things being equal, they buy sustainability over, but they're really solving a business problem. I mean, they're solving an engineering problem. And our job is to give them something that works and get it to fit inside their budget, and then remind them that, hey, this is a good idea because the business case closes, and you get this case for sustainability for free. The sustainability comes along with it.
There's also argument against the correction to, like you said, I mean, the carcinogen of creosote, right?
Yeah,
And
we don't flog that too much. It kind of speaks for itself.
yeah,
I think the railroad does a tremendous job keeping their railroaders safe. I think that it's a pretty safe industry considering all that they do.
gotcha.
Um, I don't think anybody you don't really need to be reminded of that.
Yeah, I got you. It's just it's there. It's not a punch that needs to be pulled in order to
Yeah.
make this. Is the Excuse me. So, how's the adoption going of this? How's the proliferation of these tricks? Are you making
Yeah,
good headway so far? Is there strong
we
interest?
so one of the things that I think is a signal is last month we announced that we took on a strategic partner who made a significant minority equity investment in our company. And that company is Sumitomo Corporation. So Sumitomo is, one of the, handful of these um, incredible Japanese trading companies
Mm.
that work all over the world.
Hmm.
Um, they have a major presence in steel. So they provide railroad steel to class one railroads and railroads all over the world.
Oh,
They
wow.
also own half of the only manufacturer of rail seats in North America. A rail seat is that, the rail sits like this and it's got to sit in like like a seat, like a little crib. And so I think what Sumitomo sees, um, they see a new category being created. Um, I think that our customers have said, we've got enough wood. Wood's going to be a problem, and it's starting to be a problem. We believe we believe wood ties are a problem. So what I would say is this adoption from this, or so this investment from Sumitomo signals a transition to a new category of railroad tie, which is this. There's 4 to 6 million wood ties that are failing in less than 12 years. Um, Sumitomo brings the reputation, the uh, the manufacturing excellence, and the capital that allows a company
Mm.
like ours, which was founder funded. My wife and I founded the company, our capital, with a we took on a limited number of investors for minority stake after the company had already been going. Is that
Hmm.
now we've got the staying power to drive the adoption, tell our customer we can be more competitive, not lose focus on manufacturing quality, robust up our supply chain, introduce new products. So I think we're at the inflection point, Mike. I think we're at the inflection point.
That is fantastic. That's great news. Partnering with that company. Let me ask you this: How much? Got a million questions still, but how much does one of the tracks weigh that you produce?
220 pounds are ties. Yeah,
It's a lot of plastics,
a
man.
lot of well, and that's the thing, right? It's a lot of plastic. I mean, it's
That's
not
a
like
lot of
yeah, it's
plastic.
not like oh, we make we make a marker cap from recycled plastic. I mean, it's a lot of plastic.
No,
Hundred
you're locking in a a ton. I mean, not a ton, obviously.
well
Almost
every 10 times. Ton.
every 10 ties is a ton of plastics, right? Exactly. I mean, and it's that's a ton with two N's and an E, right?
Yeah, it's a lot of
Uh,
plastic. Yeah,
not just a TON, a
yeah,
TONNE
yeah.
ton. That's amazing. So let me ask you. So what is the significance or the impact? Are there impacts on international trade laws on the adoption of your plastics? Right. So, in other words, does Scope 3 and use of vendors, et cetera, figure into those that are moving product on the rail when they try and sell it to, say, Europe? And when Europe is looking at, okay, we want to know the green, your GHG emissions, your carbon footprint, we want to know your sustainability. We got all these laws outside the United States that say, okay, how sustainable are you? And we all know those are reaching further and further into your supply chains, right? So does a railroad utilizing these ties have the ability to say, look, your scope 3 is even lower now because look, diesel per mile or diesel per ton mile, I guess, is how they measure it,
I have
is so good.
never,
But then there's carbon
yeah,
because we're not replacing the ties. Then there's sustainability because we're recycling content into our ties. Does that ever figure into it, or it hadn't gotten that deep yet?
has not gotten that deep yet, but it's worth looking at. I mean, it's a piece of the value prop that we've never amplified. Is what happens when you're able to say, you know um, the metric of merit is called millions of gross tons.
Okay.
So say if you'd say, hey, for every MGT, million gross tons, we've got this sort of benefit because as we go from the rail bed up, the tie to the tie plate to the steel, the locomotive, that
Right,
it, you
right.
know, yeah, every bit counts.
I mean, if you remove the tree, you're removing a certain capacity of carbon sequestration, right? And as that thing, as it as the wood decays, it's releasing that carbon back into it. And with the plastics, that's it'd be
Yeah,
interesting to
well,
see
it's
what that
really,
model of people at Ecovadis or something like that would be the ones that you'd
yeah,
have to go to those engineers and
yeah, that's interesting. One of the things that there's a whole association for wood ties that we're not allowed to belong to called the Railway Tie Association, but composites aren't allowed to be in it. And they say, well, when you use a wood tie, you're actually sequestering carbon. And you're like, wait,
yeah, yeah,
wait,
yeah,
what? Yeah, well,
yeah.
yeah, because it's made of carbon, but you cut down a lung, to stick it in the ground. And then to your point, it as it rots, it releases carbon, and
It's
then
exactly right.
and then when it goes to landfill, it turns to carbon. And so,
And it decomposes and causes methane and other NOx.
yeah, so it's a funny bit.
It's
And
bastardized math, is what it is,
yeah,
Tim. You know
yeah, it's a
that.
funny bit. And we've kind of said, to our customers, and again, this is like, the 10th piece of the value proposition, which is, you're building a carbon mine that, 30, 40, 50 years from now, someone is going to figure out what to do with these carbon
Yeah,
molecules. Someone's going to figure it out,
sure they are.
and so instead of going through and, mining the landfills for plastic, you're going to have a carbon mine just
You absolutely are, and I
sitting
mean,
right
but I
there.
mean, in reality, you're starting to you're at the very precipice of starting a plastics mine. Really, I mean,
That's
if you
right.
had
That's right.
right, because now you take all these, and maybe not, maybe it's more of a circularity thing because all you're doing is you're not all you're doing. It's very very important what you're doing. In my humble opinion is you're basically sequestering plastics,
That's right.
right?
And that's what we say. We say we're sequester. That's exactly the term we use. That we're sequestering carbon. We're sequestering carbon until someone figures out what to do with it. Because the circular economy, I mean, it sounds great, but if you have 100 pounds of plastic, it makes one round trip. There's 8 pounds left. Makes another round trip, and there's 12 or 14 ounces left. Then it makes one more round trip, and there's nothing left. I mean, so two round trips of 100 pounds of plastic, yields not a lot.
Oh, but that's a product or an inefficiency that's baked into the current circularity supply chains, right? I mean, if as we grow the efficiencies of the supply chains, doesn't that get better? That retention of volume get better if this
For,
it's
for
just circular supply chains, right? I mean,
well,
if I
as
mean,
long
because
as
we're only recycling 8% of the plastics, right? And that's what
no,
you're
right,
referring.
that's right. I mean, there's going to be, problem. I would imagine what happens is that as the scarcity of recycled content, the scarcity, excuse me, the scarcity from a demand side goes down because more people want it.
Yeah.
What I get, what you'd want to see is more recycling capacity brought online,
Right. Exactly.
which
Exactly.
would create deeper behavior change in people to actually recycle stuff,
Yeah.
which is going to be a signal to the virgin guys to bring more capacity online,
Right.
which drives down the price of virgin. So
Yeah.
if you're using recycled, you're like, yeah, I might as well use virgin. And the price for recycled collapses. And then people don't want to put capital in, right? So it's this, it's
It's a cycle that keeps going and it perpetuates itself until, well, you've got to have those drivers to make that happen. And that's what a lot of the legislation are talked about, the extended producers responsibility acts and all those other kind of things were intended to try and do, is to try and somebody's got to break that cycle
no, that's
to
right.
get
That's right.
moving,
100%.
and trying to make that happen. I love what you guys are doing because I mean, once your ties, and you don't have a tie that's failed yet, but let's move forward 50, 60 years, 70, 100, 300 years, whatever it is. I guess if you leave the tie there long enough, it'll eventually decompose in 500, 600 years or 1,000 or whatever it is. We don't no
10,000
idea.
years. Yeah. Yeah.
10,000 years, and we probably won't be running around by rail by that time.
Yeah.
Right?
I mean, yeah,
So
right.
I mean, it doesn't ever have to be really in a foreseeable future be recycled. But if you did have to recycle it because let's say something happens, there's a train wreck and we got to replace these ties or whatever it happens to be, they can easily just be chipped up, melted down, and made into something else.
No, that's right. And there's going to be, there's going to be um, some number of our ties that fail because that's what things do, right? I mean,
Yeah, right, yeah.
so, but you got to keep in mind that the railroad and its tie infrastructure is a redundant system. That's why they're placed, 20 some odd inches on the center for redundancy. So the question is, are one of the things that happens with a
Oh,
composite tie is that if 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 the ballast gets washed out and it gets in a fulcrum condition, our tie can break. Well, that's going to have you doing better ballast management. That you're going to shift, $100 of maintenance into $10 of maintenance to make sure that your ballast management is a little bit better because you want to take care of these composite ties. And some of them are always going to break. And then you pull them out and so one of our chief engineers that's on our team, he said, yeah, some percentage of your ties are going to break. Say it's 5%. 5% is less than 100%.
yeah, yeah, no,
But
yeah.
5%
Last I checked.
5% is a lot less than 100%. And as you install them, you're going to figure out use cases where they don't work, and you're just like, doesn't work in that use case. But it's
Yeah.
going to work in 95% of the use cases. It's going to work in a lot of use cases. And it just requires, thoughtfulness and better engineering and, lots and lots of things.
That is really, really interesting. So when you're the content, and I'm all over the place because I just think of these questions as we're going, but the content of plastics that you're using, the post industrial or post, PIR or PCR, whichever it happens to be, um, color doesn't matter, does it?
Oh, it doesn't matter.
So right there, your methodology and what you're doing in a product you're building increases the ability to recycle just like that.
Yeah, it doesn't need to be sorted by color. A lot of what we get, say half, is already black, so it's got carbon black in it. We just add some carbon black and we make it all dark.
Yeah. So you add to keep it
Yeah,
dark.
yeah, to keep it
Is
dark.
is that is there a reason for that other than that's just the way it is?
Yeah,
Or
you just kind of a finished product. You want it to look a certain
yeah,
way, and then
yeah.
you want a little bit of the UV protection that comes from
Oh, the
from
carbon. Yeah.
carbon black.
Yeah, you don't want a yellow tie and a red tie and a green tie and a brown
Yeah,
tie.
yeah.
Although that would be pretty cool to have.
It could
I don't
be.
know.
It could be cool.
Could be kind of freaky if you were anyway. It's kind
Could
of
be.
cool.
It could
It's
be.
kind of cool. So international, is there international demand or
Yeah,
for
there
this?
is.
And is there a difference between domestic and international at this time?
Yeah, yeah. The biggest difference is in profile. So our profile is 7 by 9 inches by 8.5 feet. So some profiles are 6.5 by 8.5. So there's just different profiles. There's
Oh,
different.
because the rail is not the same in Europe, is
Yeah,
it?
yeah. The gauge will be different. They'll,
Mm,
so we're exploring. We know that there's a market, UK, Australia, Germany, South
sure.
America, parts of Asia, and a great opportunity with our partner Sumitomo is that they've got channel access to all of these customers. So we started exploring, whether it's by export or whether it's building local manufacturing. I think there's a big opportunity there. There's a company called Sekisui, that is a Japanese chemical company that manufactures. It's a tie made from polyurethane,
Mm.
that is not dense and very strong. So think of it as light and strong, but it's 4 or 5 times the price of our tie. So they've been successful using a specific standard called the Japanese International Standard to get this tie spec'd into, specific high speed rail opportunities.
Oh, okay.
So yeah, I mean, it's kind of hard to see over. That's maybe like two mountain ranges away, and we're kind of scaling
Right.
the mountain. But our belief is that, with the abundance of recycled plastic, um, we should be making lots and lots and lots of things for industrial applications. You know,
Well,
affordable.
I would think so. I was just going to ask why if I mean if you're going to run a locomotive train, over the stuff, it's a little bit of weight, so they're fairly strong.
They're very strong. Yeah.
So I mean, there's a bunch of different industrial applications for this besides just railroad ties, right?
Yeah, moorings,
It-
pierings, telephone poles, utility poles. I mean, a lot of that technology now is pultruded, which is, kind of an expensive way you kind of pull and wrap these things. It can be, kind of expensive. Our question is there another more basic way to build some of these structures?
yeah,
Using, pultrusion is expensive, using more of an extruded approach.
yeah,
But one of the things that we did, Mike, that I think, we're proud of, and is that, startup 101 is that optionality kills startups. And a lot of times what happens when you're in a startup is that you got time and energy and capital. You get to the half yard line, and that's where all the resistance is, at the half yard line. You're like, oh, we've made all
yeah,
this progress. We're at the half yard line, and you're like, well, let's do something else to see if we can get something else to go faster.
yeah. Get across that half
And
yard
and
line.
and what happens is then that one gets to the half yard line. And
Yeah,
so one of the things that we did that we're proud of is that, there's other lengths of ties. There's 10 by 10 inch ties. There's 4 by 6 inch ties. There's half ties. There's long ties. And we're like, we're not doing that. We're gonna make an 8.5 to 10 foot tie that's 7 by 9 inches long, and we're gonna not do optionality. And I looked at, it was one of the lessons learned from a handful of other companies that tried to do this. All of them entered other markets, and if you're extruding something, the tooling's really expensive. It's not like it's, you know,
yeah,
you gotta pull the mold off, you gotta put the mold on, and so we said we're not going to do that, and so we're just optimized to do the biggest, fattest part of the market, which is standard railroad ties.
yeah. There you go, and stick to that. That go. That's
Stick
great.
with that.
That is great advice. I was going to ask you what advice you might have for somebody that's looking to do something like like
Well,
you're doing
don't
right
do
now.
it. Don't do it.
Besides, don't do it.
any yeah, any founder when they get to where we are, it's like don't do it. Uh yeah, I mean, I would say three things. Is one is you gotta solve a problem. Like
Yeah.
solve a problem. A lot of startups, they're like, oh, we have an opportunity, but you gotta sell a painkiller, not a vitamin. And
Hmm.
a lot of startups get in the vitamin business, and you got to be in the painkiller business. And the second is you gotta have a strategy, meaning that it's better if it's a good strategy. Um, but you got to have something to guide your thinking every day. You've got to, and we had one which was attack all the class ones, um, build relationships with the class ones, and if we couldn't convince them, we didn't try to convince them. We just went to the next one until we got adoption. Um, and then the third is that it's the team, the team, and that's really rooted in you got to care for your people and not
Mm.
care about them, but care for them. And in our business, our frontline manufacturing guys are, mostly formerly incarcerated guys. It's an unskilled labor job. We offer, living wage, 85% of their healthcare premiums, 401k
Nice.
match.
Nice.
We do all that stuff that, business can be and should be a force for good in society. And so we're kind of working at that friction point that with that group of great teammates.
That's fantastic stuff. Tim, it's been a pleasure, my friend. I'm
Yeah, love
so
Mike.
glad that
Been
we were
great, man.
impressed. It really has. Thanks for coming in. Hey, dude, win the day, my friend.
Win the day. Very Diem. That's our saying for this year. Win the
Vincere
day.
Diem. I know. I saw it on your shelf back there. I saw it up there. Your thing up there on your shelf. I went to Mercyhurst University in Erie, Pennsylvania. We were Carpe Diem.
There you
Is
go.
our motto.
That's
So
right.
Vincere Diem. I love it. Everybody else, hey man, Vincere Diem, my friends, and peace and love to everybody. Thanks for downloading
Thanks,
and
Mike.
watching. And next time we'll see you guys around. Peace and love,
Thanks.
everybody.
Bye bye.